Thank you for all joining us here in person in the auditorium as well as online. We are here for our weekly research seminar talk here at the Hatfield Marine Science Center. My name is Chung Chung. I'm the academic program manager. Again, thank you for all for joining us today. Today we have a hybrid talk, so it is online as well as in person. We have a couple folks helping with support, Cinnamon Moffitt, our research program manager, and Michael Banks with the Coastal Oregon Marine Experiment Station. So we're really excited to have our speakers today. This came about as a result of a coastal field tour that our summer interns did earlier in the summer, learning about the coastal region and restoration projects, agency collaborations and partnerships, advocacy, as well as some of our partners and resources in marine science, including our University of Oregon partner, Oregon Institute of Marine Biology, South Slough National Estuary Research Reserve, and OSU's Port Orford Field Station. Before I go into that, I do want to go over some basic logistics. For those online, we have your mics, cameras, and screen share off. Please keep your questions at the end. You can post them in the chat at any time. We'll answer those questions online. If you have a question at the end, you can raise your virtual hand and we will call upon that, as well as folks in person here on site. We ask you raise your hand and we'll bring the microphone to you to ask your question. For those of you in the room, this is recorded. So with that, you can go to our HMSC website page and look at our past seminars page, as well as we have a YouTube site that also has a lot of our recorded seminars, as well as several other talks. A couple of announcements I want to make, which is we're coming down to the end of summer session 4. And so we have our summer session students finishing up this week, as well as we have our summer coastal interns here at the Marine Science Center, as well as the Port Orford Field Station that are finishing up next week. And they'll be giving a number of talks and research posters next week, this time, well, not this time, but next week from 8:30 in the morning on Thursday to 2 o'clock in the afternoon. The morning will be filled with oral presentations from our Marine Studies Initiative interns, as well as some of our REU interns, Research Experience for Undergraduates, as well as our Oregon Sea Grant Summer Scholars who are presenting fully remote. And in the afternoon from 12 to 2, we will have research posters from MSI interns with the Innovation Lab, the Research Experience for Undergraduates, as well as Branch Experiment Station interns. So we've had close to 45 or more summer interns, undergraduate interns doing work. So we really came back with a vengeance as far as doing projects. So those are the announcements. We will post those in the HMSC community listserv and share those Zoom links, as well as the details around that schedule. So with that, I'd like to introduce Dr. Suzanne Fouty. She's a retired Forest Service hydrologist and soils specialist from the Wallowa Whitman National Forest, spending nearly 16 years in that role. She received her PhD in geography at the University of Oregon. And we also have a second speaker, Paul Engelmeyer, who was our sanctuary manager for is still also the sanctuary manager for the conservation at Audubon Society of Portland, working with 10 Mile Creek project just south of here near Cascade Head, as well as serving 25 years on the MidCoast Watershed Council, where he is currently the chair. And then finally, if those hats aren't enough, he has another hat as the Central Coast Preserve Manager with the Wetland Conservancy. The TWC, the Wetland Conservancy, in 2006 brought him on to work on the Central Coast ecoregion, particularly with his deep understanding of landscape conservation. He's been a key in building the health of our properties on the Central Coast and evaluating how they can help steward conservation in the surrounding areas. So with that, I'd love to give, and would you join me in welcoming these two speakers to our seminar today.
Oops, sorry. Pause it. Thank you very much. And I guess I have to ask Cinnamon, I seem to be having a problem doing video for myself. So I don't know if you can fix that or not. So while you guys, at some point I will show up visually, but because we are on a tight schedule and both Paul and I have a lot to share with you, I'm going to leap right in and begin my talk. I have titled this Partnering with the Wild to Tackle Climate Change. And I think that as we go through, what you are going to see and hopefully emotionally as well as intellectually experience is that this truly is a partnership. And that as we begin to think of how do we tackle climate change, partnering not only with other human communities, but also partnering with our wild neighbors is going to be one of the ways that we are actually going to collectively make it through. We're in trouble. The earth is getting hotter, and I think all of us are very aware of that, especially right now. This graph right here shows the percent of Oregon that's been in moderate to extreme drought over the last 7 years. And I don't yet have the 2020 numbers posted on this. But what we see is that out of the last 7 years, we have had 5, all right, a second, there you go. We have 5 of those years in which more than 50% of the state was in moderate to extreme drought. And we had 4 years in which 75% or more of the state was in extreme drought. And we are experiencing drought again this year. So this is our new normal. Here was May 10, 2022, and here is August 9, 2022. And again, we see large swaths of the state are in drought conditions, which is putting tremendous pressure on our wild and human communities, our agriculture, our municipal watersheds, and just generally life in general. So as these changes take place, what we're seeing is that the snowpack, which is our water reservoir in the past, it is changing in terms of the timing of melt, the amount of melt, and its dependency. I mean, its dependability and its predictability. And the result is that things are becoming increasingly unpredictable with this water yearly paycheck. And this water yearly paycheck shows up in our human constructed reservoirs. And for those of us like myself in Eastern Oregon, I drive by Phillips Reservoir, and it is a puddle, and that's all it is. And yet it holds, during the abundant years, considerable water. Okay. Here are just some examples of how that stress is manifested among the wild and the human communities. You know, we've got stress that is felt by livestock. We have stress that is felt by farmers and cities, and it shows up in our newspapers, conveying this level of anxiety. We have this stress expressed in death of salmon and death of a lot of other animals that just cannot find the water and the habitat that they need in order to survive. The other thing that's happening is that our water conflicts are in fact increasing. And this means that at a time when we need to be pulling together and actually looking for solutions and beginning to restore and accelerating restoration of our stream systems and of the other life support systems on this planet, we are becoming increasingly antagonistic. And we're not going to get through this challenge taking that strategy. So we're going to come back to the Klamath Basin again at the end. But what I want to point out is that the Klamath Basin water crisis is not an act of God. Neither is climate change. It is a result of decisions made by those in power to benefit those with power. And we need to keep that in mind. And because of that, it means that there is hope for change. All of us are going to be impacted by climate change because the scale and the magnitude of the impact is just too great. But I think it becomes incredibly important that if we're going to get through this, we also acknowledge that not everybody feels the effect in the same way. If you are a salmon and your temperatures are lethal, you are experiencing it very differently than a human being that can go into an air-conditioned house and stay cool. If you are a community that is poor, a community of color, a rural community that doesn't have much, or just your water availability is coming out of pipes with lead, you are going to feel those impacts a lot sooner than everybody else. So one of the things we need to do is recognize that not everybody is affected to the same degree. Not everybody feels the same sort of risk. And the problem is that those in power and those in ability to make and affect change oftentimes are those that feel the least impact of climate change at this point in it's happening. So with that's kind of your current state of affairs. Now what we're going to do is go on the transformative power of beaver and their dams. And this transformative power is not only on the physical landscape and what that means for an abundance of wild and human communities, but also what it means in giving us a model of what does generosity look like and how might we begin to reorganize how we engage in tackling climate change with the idea of how do we become more like a beaver? How do we create systems that enhance the benefit of people far beyond our immediate community? Here it is, the beaver, this adorable animal, and it really is pretty incredible. And this particular beaver is actively building a beaver dam. They are on the job 24/7. And as they build these dams, whether they're in forested landscapes, they begin to create what I like to call is a water savings account. If our reservoirs, our human constructed reservoirs, are being increasingly finding themselves with periods of time with limited water because they're responding to the snowmelt, what we have to do is create water savings account. And we can do this by these micro reservoirs scattered across the landscape as a result of beaver dams. And so this is in the Mount Hood. And here we have one in Eastern Oregon where I live. And these beavers are out there and they're maintaining it. And the magic of this, once you begin to transform a landscape that is dry with abundance of water, is that these beaver do not say, I'm only going to help you if you're X, Y, or Z. They just do their thing and they transform. And all who wish to come and be in this space are essentially welcome. So here's a wonderful story to make you realize and to help you see just how fast change can happen. And that this is not geologic time, this is not decades, this is in years. So here is Susie Creek, Nevada. It's a wonderful story. It's becoming increasingly shared. In 1991, the BLM and the ranchers came together and finally agreed, yeah, this is not the kind of habitat we like, and they made a grazing management change. When you look at this, you can see that the stream is wide and shallow, there's no riparian vegetation. It's terrible fish and wildlife habitat, it's terrible for livestock grazing, it's terrible for downstream human and wild communities, it's just not a good condition. So what they did is they made a change from season-long to spring and fall grazing. This allowed the riparian vegetation to basically grow during the summer months. And they also built fences to create management pastures. By 1999, this is what it had looked like. The riparian vegetation had expanded. And as it expanded, the sedges and the willows appeared and they trapped sediment. The stream narrowed down, the bank stability went up, carbon sequestration began to increase. You began to see this increase in complex fish and wildlife habitat. What's really amazing, 8 years. That is not a long time. In 2003, the beavers show up in this area, and we see this dramatic increase in water abundance above, which is in the ponds, and below ground, which is in the soil. Carbon sequestration has gone way up above ground in the riparian vegetation and below ground in the rooting mass. Fish and wildlife habitat is dramatically expanded, as has the benefits to other downstream communities. So here it is, these three pictures juxtaposed to each other. 91 to 2007, 16 years. That is not very much time. 1999 to 2007, that is 8 years. And in many cases, grazing management has changed enough to put us more in a 1999 condition than a 1991 condition, which means if beaver are allowed to move into these areas and build and maintain their dams and expand their presence on the landscape, the speed of recovery is going to be fast. Here's just another oh wow kind of example. 1994, Maggie Creek, also Elko, Nevada. The red is infrared. It's where the riparian vegetation is. You notice there's not much. It is along the stream or in these side channels here that are tapping into groundwater. By 2006, because the beaver had moved in, a similar management chain had taken place along Maggie Creek. The beaver moved in, they had built their dams, and you see this expansion of red, which means it's an expansion of the green. The riparian zone has expanded. The result, an increase above and below carbon sequestration, water abundance has gone up, as well as fish and wildlife habitat. This is a time scale of 12 years. This is nothing. It makes the possibility of change amazing. In 2006, Elko, Nevada wasn't having a drought. So this was lovely, but not sort of super exciting. But in 2007, it was in an extreme drought. And as a result, this became really important for the survival of those human and wild communities that depend on Maggie Creek. And what I want to point out is that this is not something you turn on and off like a light switch. You don't say, oh, next year we think we might have a drought, so we won't trap beaver. You have to realize that you're building a partnership, and they have to have time to expand in their numbers, in their families, and build and maintain those dams and have those dams expand. So when the drought hits, your system's ready. Here's 6 years later, Maggie Creek again from the air, just a visual to give you the contrast between this very dry landscape and this lush, riparian, water-rich landscape. If this can happen in Nevada, it can happen anywhere in Oregon. And again, in 2012, as a result of the management changes, beaver basically, what we saw in this drought period is water was abundant and so was habitat. So Oregon streams, the message here, can be transformed from water scarce to water abundant in less than 20 years. So how did these beaver dams, how do they help us get through drought? The ponds, the dams leak. So the ponds give to the river, which gives to the communities locally and downstream. As the water begins to drop in the pond as a result of drought or late season decline in incoming flows, that groundwater that's been stored moves into the pond. The pond continues to leak. The water goes into the river, and the river contributes to local and downstream communities. Now, what's happening above, that's what's happening above ground. Now, there's this other incredible thing when we talk about climate change is how do we bring new carbon sequestration zones online rapidly? Many places have meadows that are now dry grasslands. So what we have here on the right is areas with no rest. They have been repeatedly grazed by livestock. And what we see is very little above ground biomass and very little below ground biomass. But as a result of rest and changes that happened as a result of that rest, we see this increased amount of organic matter above and below. All of that is sequestering carbon. But it's even better than that, because what happens in the process of all that organic matter in the soil is the ability of the soil to hold more water goes up. And as a result, during a drought, your soil is able to provide more for the vegetation that's there. North Fork Burnt River, this is a place I know well. It is Whitney Valley, and what you see is it's wide, incised. And as a result, we see that kind of damage all across our streams and our headwaters. And the result is the water comes together, collects rapidly in a storm, and it heads downstream and it floods these areas. So how can beaver help with that? So this is a standard hydrograph. This is what you see in a lot of places. The peaks are rapid rises in stream flow and rapid drops. So I want to point out this peak right here. This is June 4th of 2010. The North Fork Burnt River and this area over in Eastern Oregon where I live had a rain on snow event. Everything melted really fast. The streams rose rapidly and then they dropped rapidly. That meant that no water was stayed and stored in the stream. So here is what Camp Creek, which is a tributary to the North Fork Burnt River, it's upstream, looks like in summer and in fall. This is a fall picture. So you see the channel is down below, and then it's in this very wide channel. On that day, and this is just lucky I happened to be there, during that high flow event, the big channel filled all the way up to the top. But it was so big as a result of past land uses that none of the water flooded the valley floor. So that water came in and it left. There was no groundwater storage. There was no helping raise the water table. If beaver dams had been present, what would have happened is the channel would have been partially full, or maybe all the way full. And so when that big slug of water started racing down, it would have interacted with the full channel, and the only place it could have gone would be over those dams and out onto that floodplain. And that means you would get a whole lot of groundwater recharge taking place. It would slow the flows down as the water flowed across the valley bottom. And so it would help decrease the peak. So instead of that big peak rise and fall, what you would get is a much broader peak. And so it's less damaging. So let's take a look at water quality. In Oregon, Department of Environmental Quality keeps track of our temperatures. And let's keep in mind that beaver cannot build beaver dams on all sizes of streams. So they tend to be able to build on a size we call fourth order or less. And in the state of Oregon, according to the Department of Environmental Quality, we have over 290,000 miles of stream of that size. Some of those streams have some water quality parameter. And of those, some of those have temperature data. And what we're seeing is 78,000 miles in the state are listed by the Department of Environmental Quality as being too hot. What does too hot mean? North Fork Burnt River, again, where I live, this is an area I spend a lot of time studying. So I'm going to use some examples here. The yellow dots are the places where you have temperature monitoring sites. The red dot is a small piece of national forest that is controlled by beaver dams. So what I want you to do is, these are the 4 sites that are on the main stem of the North Fork of the Burnt River. This is the summer maximum from 2015 to 2021. Notice that the temperatures are in the high 70s to high 80s. The temperature standard for red band trout is 68 degrees. I think you can realize this is not good fish habitat. Here is what the beaver dam controlled reach looks like. They were reintroduced in 1992, and then and there was also somewhat of a management change. And so you see this very lush vegetation that has developed as a result of the higher water table. Here again is Camp Creek, a similar sized tributary to the North Fork Burnt River. It does not have beaver on it, and it is livestock raised. So let's just take a look at the magic that happens in this very short reach that is influenced by beaver dams. So on July 15th of 2017, on Trout 5, which is coming off private ground, the maximum temperature was almost 78 degrees. After it had flowed about 500 feet, linear feet through the beaver dam reach, it had dropped 6 degrees. It was now 72 degrees. The North Fork of the Burnt River, as it comes off private ground, was 82 degrees, way too warm. So how do stream temperatures, why are they cooler in these beaver dam reaches? Ponded water is deeper. Long wave and short wave radiation only goes so deep. So a portion of the water column stays cooler. This gives fish an ability to find areas where temperatures are more manageable. The less vegetation on that area adjacent to the pond shades the ground. That means that near surface groundwater is kept cooler. And that cooler groundwater basically returns to the stream. So you have some additional mixing. And as a result, you get this drop in temperature. Now, the question is, if beaver move in, can they make the change? Oh, is that just, how do I know? So we're going to look at North Fork Burnt River 3 upstream, North Fork Burnt River 2 at the bottom of that private land, and we're going to look at those 2 trout sites. So we have data from 1997, and what you see here is the North Fork Burnt River 3 above Whitney Valley is always cooler than the North Fork Burnt River 2 below, but they are mimicking their pattern. Here is what happens in trout. We have 1997 data. Interestingly enough, in about 2008, we start to see that trout, one, where the beaver dam reaches, is cooler. And then we see this continued drop. So it's because the beaver dams are now finally having an effect. If we look at the maximum temperature, the degrees that the stream exceeds the temperature, we're looking at anywhere between 10 and close to 20 degrees. We see again, all of a sudden, because of those beaver dams, yes, it's still exceeding, it's only 500 linear feet, but we see this decrease in how much. So now you're some years barely exceeding the state temperature standard, and sometimes just as much as 5 degrees. Number of days you exceed, because remember, if you're a fish, it's not just about if you have a hot day, it's if you have a lot of hot days. So in the case of the North Fork sites, 50 to over 80 days, you're exceeding the temperature standard. And again, we see this dramatic decrease in the number of days. This is a direct result of the beaver dams being present, not just for 1 year, but for multiple years. Post-fire, the thing is that they also help us here. And how do they do that? That green area doesn't burn. So it protects water quality, and it does that by, because you've got the green, and green doesn't burn. And that means as that sediment comes pouring off that hill, it interacts with the vegetation and is trapped. Or if it gets into the beaver dam, it's trapped. And as a result, the downstream water quality stays good. And also all that vegetation keeps those stream banks strong. And then you don't get channels widening. You continue to maintain your floodplain and your stream connection. And downstream, the flooding is just less. And the also thing is that during that flood event, all those water savings accounts, those water tables are getting receding water. Now, the other cool thing about beaver is that beavers help, if we have them in abundance, help all of these state agencies meet their mission and their goals, okay? The Governor's Water Plan, DEQ, the Oregon Conservation Strategy, OWEB, and the Department of Fish and Wildlife. If we had beaver in abundance, they would help all of these federal agencies meet their mission statement. So you need to think, wow, they can do all these things and they can help meet all these mission statements. So because I have to make sure I don't go over. I'm going to quickly go through this, and because this is being recorded, you can spend time and looking and see what each one of these says. But here you'll see as you go through these, there is a common theme: secure, safe, resilient water future for all. We see the same in terms of we got to protect water quality, we got to restore watersheds, we got to protect and enhance our fish and wildlife. You know, all of these things are talking about restoring function. We need to take care of these conservation strategy species. NOAA, when you read this, you'll see there is an importance to restore the threatened coho. And all of these agencies benefit because beaver can enhance fish and wildlife habitat, improve water quality. Okay, so with all the mightiness of the beaver, I'm just going to have to go through this quickly, unfortunately, is why do we not have them in abundance? And how do we partner? Because a partnership is about give and receive. So what we have to do is first, we got to take care of our own personal carbon footprint. All right, so we've got to decrease what's going into the air so that what goes into the ground, we start to see a decrease in the amount in the atmosphere. There's going to be conflicts with beaver. They like to build dams, and sometimes they're in places we don't like. So we've got to take proactive coexistence strategies. We need to improve riparian areas on federally managed public lands, and we're going to have to do that either by removal of livestock grazing, or we are going to have to enforce high-intensity management with clear, quantifiable standards and require use of coexistence strategies for living with wolves. That's another talk, but the bottom line is we have to give them habitat, and we have to give them as much habitat as possible so they can expand habitat. And finally, we need to end commercial and recreational beaver trapping in Oregon on public lands. So here is currently a state of lands that are opened or closed. Blue means they're closed. Most of the state is open to trapping. This is what the public lands, the federally managed public lands look like. So there's a lot of it. So if we took this and we closed all the federally managed public lands, The blue indicates areas that can receive beaver benefits over time in many of these areas. Will every single stream be able to take a beaver? Have beaver families building? No, but will many? Yes. What is important to realize is that less than 200 people in the state of Oregon trap and hunt beaver on Oregon's public lands. So why are people hunting and trapping? Some people do it because they cause problems and they're not aware yet of how to manage and how to coexist. But there are people and tools out there to help them do that. And there are watershed councils that are assisting landowners, so it doesn't have to be an either or. Some people kill beavers because they think it's fun and it might make them a little bit of money. A beaver pelt is worth about $12. For the last 20 years, ODF&W has had greater than 51,000 beaver reported killed. The U.S. Fish and Wildlife Service has killed 10,000, and then private landowners have killed some unknown number. This is just an example of the different numbers that have been reported to ODF&W. It looks like there is a decrease in the number of beaver that are being killed, but there's an important caveat. In 2005, there was a change in the regulation, so private landowners did not have to get a permit, and it may have also changed reporting. And then in 2013, it was made clear that there was no reporting required. So what I would say to you young budding students and scientists is that data must always be looked at in context. There have been 4 recent efforts to try to change beaver management on private and public lands, and they have all failed. And I would normally want to go through these, but I am basically going to go to the end of my talk because it's time for Paul. Just a minute, I want to get to my I will just say one last couple things. There's tons of science. This gives you an example of the publications. There are studies that say if you close trapping, we will get a positive impact. And given that our yearly paycheck is dwindling and we are continuing to see these impacts, given the fact that the Klamath is a great example, a big chunk of it's public land. We've lost over 1,000 beaver in the last 20 years that we know about. And we're at the choice point. We can maintain this trajectory, or we can have all of these incredible benefits. But to have those, we have to have the beaver. And so with that, I turn this over to Paul.
Thank you, Suzanne. Can you folks hear me out there? All right, Tom, I'll be talking to you, making sure you're far enough away. Okay. Okay, here we go. Almost.
There we go. Got it.
So I'm Paul Engelmeyer, and I manage land again for Wetlands Conservancy in Audubon here on the Central Coast, and been dealing with conservation strategies since the late 80s, early 90s. And a number of years ago, this issue of beavers came up, and dealing with coho recovery, but I'm coming at it from this issue of water quality, water quantity, and salmon recovery. And that's why I got engaged in the Watershed Council and this issue. So, and I'm a advocate. Everybody kind of, I acknowledge that that's what I do. I'm an advocate for cold, clean water. Some folks consider that a radical statement. Okay, a radical position, not me. And I fault my dad for that. Am I getting a reverb? Is that okay? The middle one down?
Right, down.
No. Okay. Okay, I'm going to be touching on these things, and what I consider is, I'll go ahead and apologize. I've got a ton of stuff here. We'll move through fast, and then you'll be able to look and review it at your leisure at some other time with a glass of wine or whatever. So I'm going to be talking about the Clean Water Act and come at it from a different angle than Suzanne and water quality issues. And so since I'm a fish head kind of, salmon recovery is really one of my key agendas. And so it's really a sad situation where we are around the whole state. But there's a lot of action, and I have decided I needed to incorporate this education partnership effort that's going on around the state. So before we get into that, I want to make sure we're all on the same page. A little reality check, how precious this resource is. Water, glaciers, 1.7%. And then you go down and you go, okay, what's total fresh water? 0.77. How do we get to the bottom bar so we can see that? Oceans, 98%, almost 98%. What we're really talking about, beaver and rivers and fish, is 0.77. See this available and renewable? 0.0008. Is that precious or not? This is what I realize. Okay, we're back to the same position of moving forward. Backwards. There we go. Okay, Suzanne mentioned the Clean Water Act. So I went to EPA and says, I need a map to be able to tell a story of current conditions of our rivers. So I says, I want all the rivers that are on the 303D list. When I ask a question, you can say, yes, I know about it, or no, I don't know about it. So Clean Water Act, have you heard about the Cuyahoga River catching fire? Yes, okay, quite a reality check. That was only in the 70s. So we have, like Suzanne mentioned, almost all of our rivers are on the 303D list. Hers are off the charts hot. Is it a surprise? So we have 80,000 that we know about. We've got problems. It kind of blows my mind how bad it is. But so I have a couple of these things that are real quick just to make sure this riparian zone, you may have already had it in your classes, but I put it in here just as a reality check. Riparian zone, forest corridor. And so, and TMDL, have you heard of that? No. Okay, that's a plan. All of those red rivers are going to have a plan, a TMDL, total maximum daily load, a management plan to bring them into compliance. Those rivers that Suzanne was talking about, they're going to have a plan to bring it into compliance with clean water. And precipitation, snowpack, not an issue for us in the Coast Range. Our rain comes in bulk. And we got the Mediterranean climate for 4 to 5, and actually it's looking like longer months of drought. It's a big deal for us in the Coast Range. When we think about the Clean Water Act, for me, this slide is what I'm talking about. That's me with the shaggy hair and the steelhead, okay? This was before when you could kill a steelhead, okay? And so birds, recreation, safe, everything's good. Shorebirds are moving through. We've got tailed frogs, red-legged frogs, coho salmon, water for our community. That's what the Clean Water Act is about. But the problem is, it's not what it is, reality. So I said, okay, let's see how, so distinct population segments. So there's the state of Oregon, all of those, you come down to the box there, yellow, Chinook, chum, coho, steelhead, blue, Chinook, chum, coho, steelhead. All those are listed under the Endangered Species Act. Around the state or around the region, 40% of the salmon that are listed are in our state. That's Idaho, Washington, Oregon, and California. We have 40% of the ESA listed salmon. You could read this again later, but these are the same things that you'll come up with. Protecting riparian zones, restore areas, complexity, diversity, connectivity. These are same bells and whistles that have been said. That's 25, 30 years. This is what we need to be doing. So this is Beaver Creek. Some of you have done recreation there. We have helped, Wetlands Conservancy and the community has helped the state parks acquire land, and we work with the community doing restoration on the uplands, upstream, and the Forest Service, as you can see, is the upper portion of the base, helping them acquire land as well as do restoration on federal land. And so as a result of my efforts with trying to influence the Fish and Wildlife Commission, I shared the fact that our MidCoast Watershed Councils had our fingerprints on our partners on right at $100 million. And so when I was sharing that with someone, they says, man, that's impressive. Your 1 million acres is $100 million. How much has the state of Oregon spent to recover our landscapes? So that's a good question. I don't really know that, but I chased it down through this ORRI, the Oregon Watershed Restoration Initiative. It's an amazing data set, and the folks there are very much willing to help and help you navigate it. But $1.15 billion we've spent since '99. $1.15 billion. And that's almost 20,000 projects dealing with trying to improve habitat for a suite of species, which includes acquisitions, restoration projects, and research. So it's truly an amazing investment for the state of Oregon. I'm really proud to be a part of it with the MidCoast Watershed Council, Wetlands Conservancy, and Audubon. And then so when you break that out, that investment source, you see federal is a quarter, state, that's Oregon Watershed Enhancement Board. That's the big funnel of money for the watershed councils. Federal is many ESA recovery strategies, but there's investments by all of these groups, including volunteer efforts. And so when you look at, oh, what does that really go to? So for our coastal coho, I showed you all of those ESA listed salmon around the state. But here we just zoom in to the Oregon coastal coho. Current level of concern: loss of stream complexity, degraded water quality. So you go through high. So 50% of what we need to do is related to water quality. That's what those investments are going to. And all you need to do is look at what can Beaver do for us. That's 24/7. They could work on the 2 high priority issues if we have them in robust numbers. And then you drop back again and say, well, these watershed councils, look at how many they are around the state. That's us on the central coast here, mid-coast. That's 1 million acres, more or less, 957 or something like that, 957,000. And so around the state, these are folks who are private individuals who say, I'm not going to let them go extinct, or water, and we want to help improve water quality. It's very impressive that the state of Oregon has this in play. And so I'm pleased to be a part of our MidCoast, and you, of course, can see some of our past projects on our website, or engage in the nursery or planting or invasive species projects. And so we've got a really good cadre of volunteers. And then we zoom in, here's the 1 million acres, Lincoln City on the north, Yachats and Cape Perpetua and Cedar Head on the south. And that's the 1 million acres, and those are hydrological planning units. But this is what used to go out of here 100 years ago. And that's just north of Yachats. We had 2,000 loggers living north of town. That changed the landscape significantly. So when you look at the Coho recovery plan, the state plan or the federal plan, it's the same set of things: water quality and stream complexity, lowland habitat, ideal for beavers. So there's one on the left as you look at it, that's Wetlands Conservancy land. That's ponded water from a beaver that's moved in. And then Beaver Creek, another beaver moved in. But in that case, my buddy at North Beaver, he saw the cougar actually snag the beaver. Oh my gosh, he was blown away. Turned around, was it real? Well, the beaver was there. By the time he came back, the beaver was gone. Cougar came. That's natural mortality. They will always have this natural predation. What we can control, though, is human, the way we treat the beavers. And then when you think about this connectivity of water or salmon, It's also connected to the forest bird abundance. And so there's a Jones-Perry study. You can't even ignore the fact that the way we treated the uplands. I'm not going to go into the forest, but I would love to have more of a conversation about that. Things as simple as fog drip and connectivity across basins. All those things are very real. And it means that if we're serious about water for our communities, we need to address all of these issues. But as we zoom down in and go, well, I'm from the North Coast. Well, let's talk about Nicanicum. Is that any different? Oh, stream complexity. Oh, and Nehalem, stream complexity, water quality. Oh, look at this, Yaquina, stream complexity, water quality. Same mantra. And yet we are killing these animals on federal land. So I look at that going, I'll get into that a little bit later. But this natural climate solution and carbon, I would be remiss if I didn't draw attention to this carbon thing, and I'm glad Suzanne hit on that solidly. But the fact that we can do a better job in terms of natural climate solutions. And we've got a pretty good movement forward on this investment in riparian zone. We can do much better on the unstable slope issue. And if we're lucky, we'll have these coho on the gravel more and more. And so this is part of that acquisition that we orchestrated in Beaver Creek. And so these are bullets that Suzanne totally hit it out of the park. These are just bullets that you can go into, but I wanted to put this up because of these two documents. One's from south of us and one's from north of us. So the state of Washington, as well as down in Nevada, have these beaver strategies. So it isn't just Oregon that's struggling with how do we store water naturally and how do we recover these keystone species. And this is a couple of these bullets came from Dr. Ernie Neame. He's an economist who was on the Beaver Working Group. So he sent this little document, and at some point, hopefully you'll get to hear the full story out of each of these 7 bullets on an economic piece. So the Beaver Working Group came into play as a result of us trying to push the agency to secure federal lands for conservation of the beaver. And then this Beaver Working Group came into play, and he sent a memo in July 22 about if you're going to look at recommendations for the beaver, you should look at salmon benefits economically, cool water benefits, the economics of it, right? We can do an economic analysis on these. Did we do that, the state of Oregon? No. So there's a investment piece and a benefit piece, 2 pieces of a document that weren't even there. So I communicated as an advocate to the commission that, the document has a lot of good things in it, but 2 of these key issues aren't even addressed. So I urged them to not endorse that document. But the Forest Accord came into play basically at the same time. But in my mind, and anybody's mind would say, Forest Accord, that's good. We're definitely moving the dial a little bit, which is a good discussion point is, in your mind, how do you change? How does society change? And so I looked at that going, okay, the Forest Accord, there were a lot of folks that were really, because this waterfall one, that was legal. Okay, that's called a type N stream, non-fish bearing. You can cut right over it, spray right over it. And that was one of the issues that changed in the Accord. So that's a solid, in the right direction kind of thing. Building roads over unstable slopes. These are things that we know how with LIDAR and these data sets to do these things. Are we going to incorporate them in? They say they are in the Accord. And so here are links to the Accord right here, and links to an issue related that is very controversial, especially in the coast, probably maybe more than other locations, related to spray and drift. So there's a link to that story. But I want to show the log drive. So, okay, so here's the head nod routine. Has everybody heard of splash dams and log drives? Only one, yes. Maybe 2. Okay. It was one of the major issues. And so I look at this issue of beaver management, salmon management, forest management as an adaptive management approach. Log drives were legal. Splash dams were legal. And if you actually could go back in time and see what they were doing legally back then, And it was like, oh, times have got to change. This is unacceptable. They changed it. They says, nope, we can't do that. We can't run those logs down the side of the hill, ream out that whole thing, yard them downslope is what it's called, and then have them float in a river, create a dam, then blow up the dam. Then they just ream out the riparian zone, and then you're in the estuary, like these folks right here. This is the Siletz River. So in any event, things change. And so we're at that same point in time with this issue of beaver. The upper graph there is the number of research papers related to beaver by 10-year slot. So what we know right now, the 2010 to 2019, a lot of good research has come into play. And you just go back in time, and a lot of folks weren't really talking about it in the 70s to 80s. So in any event, I look at this going, wow, this is a good way for ODFW to go, okay, times have changed. We need to adapt our management program and value this keystone species for salmon, water quality, all these things that are so real. And as we bring it to this issue of coastal coho, which that's one of my focus, is this other one. And from where you are, you won't be able to really see the number of spawner on the gravel, which is the light red. So you can't really see that, but if you pull it up on your computer, you can. So we were in the ballpark zone of 1.5 to 1.8 million. When the Endangered Species Act petition came into play, we were in the 30 to 60,000. This is the trajectory of habitat decline all the way down into the corner down there. Now we're trying to reverse them and bring them back. And so every project that's in play and these watershed councils on the coast and the partnerships that we have. So Chris's ODFW research, and we get to bring him out and have discussions in the field with students. And it's really a pleasure for me to have not only ODFW, but the Forest Service go to projects that we worked with them on pre-monitoring for 6 years with a restoration project and telling the story about current conditions and where it's going. And of course, just the reality check is, this is new territory for us. We are putting things back together. And a precautionary strategy is not radical. Saying you want cold, clean water for salmon in your community, that is not radical. And it isn't just the beaver. Otters are trapped as well. Some of you probably know that. But here's just an example of how I get to work with the agency. So in their process, they will ask the public, what do you think we should be talking about in this watershed analysis? Well, this is a project where me as the public get to address this after discussions with the Forest Service hydrologist, the fish bio, the wildlife bio. Well, Paul, make sure that you ask the question about what roads are impacting watershed process. So see this road here? That channel wants to migrate in the floodplain. Can it? No. Rip wrap, protect it, keep it in this little trough. So you as the public get to pose the question. The agency has to answer the question. We did. We decommissioned 4 miles of road and 3 bridges. So that channel can move in the floodplain. These are things that public can do if you choose to engage, okay? And this is an helicopter large wood placement of the large wood there. You can actually see, I think, maybe you can't, but this log in the lower, that's tagged, and we were not anchored in as we want that log to stay right here to create a jam right here. We assume that's going to pulse its way through like normal. And so those are all numbered, part of the research project. So that's an example of doing something, know that you're trying to restore process. So now all of a sudden the full floodplain is interacting. You got to think about those little fry that are looking for refugia. These are little eddies and places to hide. And the fact that there's so much work ahead of us, we should acknowledge that. And that's the Forest Service, and that little creek pushed those logs around. This is private land, a partner downstream, and it isn't just for the beaver. And so our partnerships, and there's the funding source. You can see the 3 different funders that kicked into it in one of our field trips. And that's working with, again, the National Forest and OSU and U of O are ongoing field trip sites for me. And ODFW are right there with us. And this is the research projects that have been going on since 1990. And that's a lamprey if you don't know. And I'm fortunate enough to have the forestry crew, Angel Job Corps. They get to learn skills related to forestry and trail maintenance things. And I get work, go slow, but it's very positive. And there's this water quantity head to cape project that's in play here on the Central Coast, one of 4 projects around the state. And I'd be remiss if I didn't talk about blue carbon and natural and working lands. If it's not on your screen, I can send you some stuff and it'll get you up to speed on this blue carbon story. And so here are just some paragraphs that have come out, various recovery plans that point to the same thing of the value of beaver and the habitat they create. And it's all reference documents. These are coming out of recovery plans. And so this idea of clean water, you want clean water, investing in nature is part of the solution. So there's some great documents and books on that. I really urge you, if this interests you, to check that out. And engage. These are volunteers helping deal with us in the Beaver Creek catchment. Those are yellow flag iris. And yeah, pretty amazing. And climate change. ODFW put a really nice document together, this Oregon's Conservation Strategy fact sheet. And so this idea of having state's conservation strategy, the salmon recovery strategy, ESA listed salmon, Clean Water Act needs, all of these things are pointing to what we need to do. And you've got species that will help on all those things. And yet they're sitting on the sidelines from my perspective. And another, really, if you're looking for a good book, this is by Dan Bottom and a team of folks there at out of Sea Grant. Really awesome book related to pathways to resilience. And it really is, Kim and all those guys, a really great book to share about this life history strategies for survival for salmon recovery. And here are some of the papers that I mentioned. And the one in the middle, the MidCoast Watershed Council Beavers, are linked to a bunch of other documents related to videos and papers. And Suzanne, are you there? Let's see if we can see if there's any questions. I don't know how I'm doing on time. Probably close. So yeah.
All right, thank you. We are actually at the end of our seminar, but I would want to take a moment, let folks, if they need to, depart if they need to. But we do plan to have a Q&A session following this. So let's maybe take a couple minutes of a break. Right now, we'll take a 5-minute break.
Sure.
And then we'll start up with a Q&A session following. So, and we'll stay in this room. Folks online, please stay with us. But we'll do a 5-minute Q&A break, or a 5-minute break, and then Q&A session.
Sounds good.
All right. Thank you.